And now we think about how we can interpret the slope of that logistic regression model when it's in the logit form if our explanatory variable is quantitative. So for this, we're going to go back to that MED-GPA data set. So remember that we used GPA as a way to predict the probability that a student will be accepted to medical school. And in the logit form of the model, the estimated slope coefficient was 5.4. And I've just recreated the code here. We've done this before already. And based on the model summary, I just want to point out, so again, this was in the logit form. So the predicted log odds of being accepted, not probability, log odds of being accepted, are negative 19.207 plus 5.454 times GPA. Okay, so as we've said a few times already, if this were simple linear regression, that slope would be pretty easy to interpret. But in this logit transformation, it's a little bit more challenging. So this predicted beta 1, 5.454, is a typical change in log odds for each 1 unit increase in GPA. Again, what does that actually mean? So let's see if we can get it into a more understandable form. So first of all, the odds of being accepted, not the probability, but the odds for some GPA is given by, so I'm exponentiating both sides of that model equation up there, is e to the negative 19.207 plus 5.454 times GPA. If I increase GPA by 1, so I have the odds at whatever that GPA was plus 1, I'm looking at e to the negative 19.207 plus 5.454 times GPA plus 1, which I can think of as, if I just distribute the 5.454 there, e to the negative 19.207 plus 5.454 times GPA plus 5.454, which I can use the rules of exponents to write as e to the negative 19.207 plus 5.454 times GPA times e to the 5.454. So remember, if I add exponents, that's the same as multiplying like bases. So in fact, I have here the odds of being accepted at the original GPA times e to that slope value, 5.454. Or, and this again, I've been carrying down, this is the odds of being accepted at whatever that GPA value is plus 1. So if I actually do the division, the odds of being accepted at GPA plus 1 over the odds of being accepted at GPA, whatever that is, so that odds ratio is in fact e to the 5.454. So an increase of 1 GPA unit can be described in terms of the odds ratio. And if we actually do the math, doing the exponentiation, that odds ratio is 233.7. So in other words, a 1 unit increase in the GPA is multiplying your odds of being accepted by over 200. So it says in general, we can interpret the estimated slope beta 1 hat as increasing the predictor by 1 unit gives an odds ratio of e to the beta 1 hat, or in other words, the odds of success are multiplied by e to the beta 1 hat. Now, you might be saying to yourself, oh my gosh, that odds ratio is huge, and it is, but think about your predictor of GPA. I mean, if you could raise your GPA by an entire point, like from 3.0 to 4.0, that's pretty huge. So maybe you would expect a pretty amazing consequence from that. Maybe what would make more sense is to think about, like, what if I increase my GPA not by a whole unit, but by a tenth? And in that case, we can figure out the odds ratio by raising e to the 5.454 times 0.1, and we get a 1.73. So if we could increase our GPA by a tenth of a point, our odds of being accepted would be almost 2 times greater. And I just, again, parenthetically noted, because I catch myself doing this sometimes, my odds of being accepted as opposed to the probability of being accepted. We're talking about odds, which are not the same as probability. And I just have a final note there. In the model, right, that assumes the odds ratio there, regardless of where we're starting that GPA. So whether we're raising from 2.5 to 2.6, or 3.5 to 3.6, or what have you. Whatever 1/10 increase we're talking about, regardless of where the starting point is, we get that same odds ratio of 1.73.